Hi guys, welcome back. We're going to learn transformations of graphs today. And essentially what it does is you're able to change what a graph looks like without having to sketch it all over again, okay? So the order that we apply transformations in is often taught as DRT, Dr. T. We have dilation, reflection, and translation, okay? And we'll go through all of these today. So the first step when it comes to understanding transformations is you ask yourself whether it's inside or outside the function. So what I mean by this is if I have a function, f of x means function in terms of x, and I'm changing it, applying a transformation that looks like this to x plus 1. You have to ask yourself which part of it is inside the function and which part of it is outside the function. So obviously the 4 here is timesing the whole function, so we say it's outside the function. And the 2x plus 1 is within the brackets and it's inside the function, okay? So let's give you guys a few examples. So for instance, if I have my base function, f of x is x squared as our original function, and I apply this transformation. Well, let's start off with the inside function first. What you're doing is you're going to replace the x with 2x plus 1. So I'll have 2x plus 1, literally replace it, chuck it in there, right? And then I take it to the power of 2 because there's a power of 2 here. And then the outside function, I just put a 4 on the outside. And I'm timesing the whole thing. And the same thing goes for, say, if we have e to the power of x. This one, a lot of people get confused with. How would the function look like if I apply the transformation? Well, obviously, start with the inside function first. I replace the x with 2x plus 1. So I'll have e to the power of 2x plus 1. A lot of people get confused on this one, okay? And then, after that, I'm going to times the whole thing by 4, which is the outside part. So this is just a few examples. One more, this is a hyperbola. What happens? Obviously, first step is to replace x with 2x plus 1. So you have 1 over 2x plus 1. And then after that, you have to times the whole function by 4. Okay, so this is the first step when it comes to understanding transformations. So you have to ask yourself, is it inside or outside? So let's go on to the actual transformations part. Let's start with translations. Okay, but always remember that the actual order of transformations is in terms of DRT, so dilation, reflection, and translation. So translation is actually last. But anyways, translation means that you're moving left, right, up, down, okay? If you're moving left and right, you're dealing with the x-axis, which is what we call a horizontal translation. If you're doing up and down, then you're dealing with the y-axis, which means you're dealing with the vertical translation. Let's start with a vertical translation. So obviously the first step, you ask yourself, I'm dealing with the y-axis, and this happens to have an impact on an outside function, outside the function. Because think about it, if I give you, okay, f of x, and I want to move the graph up by 2, I'm just going to shift it up by 2 units, right? If I give you, like, say, x squared, right? And I'm telling you to move the down by 2, you're just going to say subtract 2. So this is very straightforward. It's outside the function. So if I say it's moving up, you just plus. And if I say moving down, it's just minus. So the word is correlated with the actual move, like the actual equation transformation of the graph, okay? But when we deal with horizontal translation, we're dealing with the x-axis this time. And the unique part about this is we're dealing with the inside function. Okay, so now if I say I want to, let's use a different color, I'll just do 2 units right on x-axis, you might be tempted to think, oh, all you have to do, if I'm dealing with the inside function, it might just be f of x, and if I apply the transformation, it becomes f of x plus 2. Wrong, angry face. No, because we're dealing with the inside function, so it's a bit different now. What we have to do is use null factor law to get f of x minus 2. So every single time you see a transformation that is inside the function, you have to use null factor law or do the opposite in order to get the actual like movement right. So for instance, if I give you guys an example, I say, okay, you guys tell me what this transformation is. So I have 1 over x, and I do this 1 over x plus 3. So what I've done is taken f of x and I've turned it into f of x plus 3. See how I replace the x with x plus 3? We're dealing with the inside function. Now you ask yourself, okay, how is the movement going to work here? So I'm going to take the opposite of that. So I'm going to use null factor law, x plus 3 equals 0. This is what it means by null factor law. You make the inside bracket equal to 0, and we imagine there's a bracket here. So x equals negative 3. This is the translation. So the actual transformation that's happening here is translate 3 units left on the x-axis. Does that make sense? So another example, if I had e to the power of x and I turned it into e to the power of x plus 4, well, once again, I know that it's having an effect on the inside function because this is replacing x with x plus 4. Now, so first step inside, second step is use null factor. And what you get is x equals negative 4. Therefore, it's translate 4 units left on the x-axis.